So there's our end grain bowl. And this one will be our pith bowl. So we have our pith somewhere around here. We'll just darken that in. And then we have our grain all the way around. We'll just make a couple growth rings. But then we have our typical end grain bowl without the pith. So naturally our shrinking is going to go in this direction, toward center. We'll say our pith was over here. But in a pith bowl, what appears to be happening is drying towards center, right? And this relative area around the pith stays wetter. And we have increased strength by whatever percent. What I think Art said it was maybe 70% at dry. So we'll just use that as a number. And then we have this whole area that is negative 70%. Right? So it's weaker. Plus, because of the pith and the extratives that get put into knots and pith, it is stronger on the surface, but according to Holdley in his book, it might be stronger, but it doesn't have, what was the property? Either way, it's inflexible compared to the rest of the wood. It's brittle. It has a surface hardness. That's what it gets. The extratives give it a greater surface hardness, but it's not structurally stronger. So out here we have wood that's not brittle, dry, and at its maximum hardness. And in here we have wood that is brittle and wet. So it's at its weakest state. And everything is pulling towards center, but it's also cupping because all of the tension pulling towards center has to be relieved somewhere, so we get our cupping from it. And the cupping action combined with the pulling towards center creates our pith cracks. Now, this results like in what you see in a log, generally, is that we get our crack here because it's all pulling in, and stress needs to be relieved one way or another because it cannot cup. So it splits. Now, in a typical end grain bowl with our pith cut out, it can just cup and pull toward this point. So it would want to cup here and somewhere around here, most likely. And that'll pull this edge up and this edge up and make it look like it's flattening out, like that it is wanting to dry across this line, like it's going to shrink more that way. That's how I see the drying process happening in here. And also we have to remember that this whole area hasn't shrunk yet. So we have, 10-15% of the bowl that hasn't shrunk, and 2-3% in the center. And this final chunk of drying generally is what resulted in the weird little pith volcanoes that happened, because that last little pinch had nowhere else to go, and what ends up being the weakest point is centered immediately over the pith, so it just goes out because it's not going to move anywhere else because this has happened to the bowl. It just doesn't have anywhere else to go. There's no way you can force this little volcano inward. It's just not possible. I have had some success with a thicker walled foot, kind of reinforcing this area just outside the pith, so that when we get movement out here, it gets stopped here and basically isolates this, because what I've seen in hollow forms is this small thick chunk of pith, and it's not checking. It's just, for whatever reason, it takes everything out of the equation in a hollow form. All of my hollow forms have the pith in the bottom, but bowls undergo a way different type of stress when drying, and it's creating these pith explosions and the fun pith checks that everybody loves to see. So, I don't know, that's just my take on what you had said earlier about how bowls dry.